Okay, so for the last question for today's class, I just wanted to go over functions, right? How do you know if a function has an inverse function? So just by looking at b of x, right, this is supposed to be x squared. I don't think they have that option to turn this into a superscript, right? So this is x squared plus 3. Then you have d of x, which is equal to negative 9, m of x, which is equal to negative 7x. And finally, you have p of x, which is equal to x. Okay, so first of all, let me just quickly show you how each of the function would be graphed based on just looking at the function. So we know that for b of x, right, it's a parabola, right? Because it's a quadratic function. So x squared plus 3. So in that case, you would have this over here. So this is 3. So you're translating 3 units up, right? That's what the plus 3 is for. And then you're pointing upwards or opening upwards because you have a positive leading coefficient because it's positive x squared. So that means if you're looking at your function, right? First of all, do you know that this is a function? Yes. Why is it a function? Because we apply this vertical line test, right? So for you to identify first, right? So before we get into inverse functions, I just wanted to make sure you understand how this vertical line test works and also the horizontal line test, which is coming up later on. For the vertical line test, right, if you draw your function, right, and you use what you call this vertical line, right, anywhere in your function, right, your function needs to pass through this vertical line once and only once, right? Once it passes this vertical line twice, then it's not a function. So for this to become a function, when you draw a vertical line anywhere, right, in your domain, right, in your function, it needs to intersect this vertical line only once. That's it. So that's how you know this is a function, right? So supposedly you wanted to know whether you have an inverse function, right? Because what they're trying to propose is you have this horizontal line test and then it's a one-to-one function, blah, blah, blah. So this horizontal line test is basically you find the inverse. So that's how you're going to solve for this. So you find the inverse. So how do we find the inverse of a function? So you have b of x, right, which is equal to x squared plus 3, right? So let's say you go and, switch up your y and x, right? But there's no point in doing that because you can actually apply what you call this horizontal line test. So this horizontal line test is literally you have your function, right? Draw a horizontal line, right? As you can see, your function passes through the horizontal line twice, right? If it does that, that means you don't have any inverse. Does that make sense? So if you look at this, right, if you have a horizontal line test, it passes through twice, right? That means if you, let's see what they're trying to say. Okay, so I guess this is for this part right here. Okay, so it says the graph of this function is a parabola, that's right. Each vertical line crosses it at exactly one point, which we've illustrated. And for the other one, it says, but horizontal lines can cross it at 2 points, which we've also seen. That means this can be a one-to-one function. So when they're saying that it's not a one-to-one function, therefore you don't have an inverse, right? So that's why this is really important because you don't have to go and look for your inverse function. That's why this horizontal line test is important. And it actually saves you time, right? To go and look for your inverse. Okay, great. So I hope you understand the difference between the vertical line test and the horizontal line test by now, so we can move on to the other questions. Okay, so as you can see, d of x is basically negative 9 because it's a constant. I mean, it's not a function, right? It's just literally y is equal to negative 9. It's a horizontal line, right? If you have d of x, which is equal to negative 9, it's just a horizontal line. So negative 9 over here. So this is how your line looks like. It's not a function. Therefore, you can't really have any inverse function if it's not a function to begin with. So, yeah, and also the vertical line crosses it at infinitely many points. Okay, great. So let's move on to m of x. So m of x, you have negative 7x, right? So as you can see, this is a linear function, right? So negative 7x looks something like this. Yeah, it's supposed to pass the origin, right? Okay, there we go. So yeah, this is negative 7x, and they're saying that, so it is a function and also it has an inverse. Okay, great. So if you have the vertical line test, right? So, okay, this is supposed to be a vertical line, so we don't need the arrows. Okay, great. So vertical line test, right? That means it's only going to pass your function once, right? And when it passes this function once, it's exactly in a unique point, right? It's only one x and only one y. You cannot have infinitely many y points, right? Or x points in this case, right? So in that case, this passes the vertical line test, therefore this is a function. Now if you draw the horizontal line right over here, it means that it's also the same way as the vertical line test. It only passes that specific point, right, once, right? And it's a unique point. Like it's never going to be the exact same point that you're passing, unlike when we were looking at d of x, which is equal to negative 9. Because for here, if you tried to have so many vertical lines over here, you can see that yes, it does passes this line once, but the problem here is it's always going to be the exact same y value, which is equal to negative 9, right? So say for example, you're at x is equal to negative 5, right? Your y would always be equal to negative 9 if you pass, like let's say here. If this was x is equal to 1, your value would always be equal to negative 9. So you don't really want that, right? So it does not satisfy the vertical line test in that sense. So if you're looking at this, because it passes both the inverse, right? So in order for you to find the inverse, you know that this is y is equal to negative 7x. Then all you have to do is switch your y into an x, and you have this x being your y. So you would have negative 7y. Now all you have to do is isolate y as you would in any function, right? So this is divided by negative 7 divided by negative 7. Therefore, your y value or your inverse function is y is equal to negative 1 over 7x. That's your inverse function. So you need to check your vertical line test first, then your horizontal line test first, and go and find your inverse. So that's the order. Okay, great. So p of x is equal to the absolute value of x. So we know that an absolute value is a function, right? So if you have p of x, so it looks something like this, right? So it has a vertex at 0, 0, it crosses the origin. So it is a function, right? Because at any point, right, wherever you're drawing your vertical line, it's a unique point, right? It only passes your function once and only once, and you're not having like infinitely many points as we would expect when d of x was equal to negative 9 from the earlier question that we've been doing, right? However, if you try to draw horizontal lines, right, at any point when you're looking at an absolute value function, well, it's passing through your function twice, so it does not satisfy. So yeah, can you see this? So it passes this line twice. So that means it does not satisfy the horizontal line test. Therefore, you don't have any inverse for p of x, which is equal to the absolute value of x. Okay, great. So yeah, I guess the explanation that they're saying so far by looking at it, they're all right. Inverse function. By the way, the only time that they brought up one-to-one function, it means for every x value that you're getting, you're going to have a unique y value. So that's what they were trying to say. So that's what one-to-one means. Okay, so yeah, I don't have anything to correct from here. So perfect solution and answer. Okay, that's it.